In this video, I'm going to be talking about the main fundamental concepts of trigonometry, and we're going to start out with the main three trig functions, which are sine, cosine, and tangent. So oftentimes people refer to this as SOHCAHTOA because it's a little trick to remember the different sides involved in the triangle for each of the different trig functions. So let's start out with sine. If you use sine, you're going to take the sine of theta. Theta is the angle, and that's equal to the opposite side over the hypotenuse. Okay, the hypotenuse is always going to be the same. It's going to be the side that is opposite of your 90-degree angle. That is the longest side of your triangle. So that's going to stay pretty consistent. For your opposite side, that can change depending on the angle you're looking at. So if we're taking a look at this 30-degree angle, the opposite end is the side of the triangle that it faces. So that 4 is directly opposite of that 30 for this particular triangle. Okay, and then the adjacent side is the side that's sitting right next to the angle, but it's definitely not directly across from it, and it's definitely not the longest side of the triangle either. Okay, so going on to cosine, we have the cosine of the angle, and that is equal to the adjacent side over the hypotenuse. So in relation to our 40-degree angle, this is the adjacent side because it is not opposite of it, and it's definitely not the longest side of the triangle. So the adjacent part is just right next to that 40 degrees. Then our last one is tangent, and we take tangent of the angle. That is the opposite end divided by the adjacent end. So that's where the term SOHCAHTOA comes from, the S-O-H, the C-A-H, and the T-O-A to help you remember those ratios for the three different trig functions. So let's go ahead and set up these three problems. So if we're taking a look at this one, we're going to take the sine of 30 degrees, and I would recognize that I want to use sine because I'm looking for a hypotenuse, and we have two trig functions with hypotenuse in it, which would be sine and cosine. So now I have it narrowed down to 2. And then they gave me the number or the side that's opposite of my 30-degree angle. So if I have the opposite side and I'm looking for the hypotenuse, I want a trig function that involves opposite and hypotenuse, which would definitely be sine. Okay, so I'm going to take the sine of 30 degrees, and that equals 4 over, and then I'll just put h for the hypotenuse. Okay, so we'll come back and solve these. I'm just going to set these three up, and then we're going to go back and I'll show you a quick and easy way to solve each of these three. For the second one, we have cosine. We decided to use cosine because we're looking for an angle that is adjacent, and we have the hypotenuse. So this has adjacent and hypotenuse. So I'm going to put A for adjacent divided by 5, which is our hypotenuse. And our final one, I'm going to take the tangent of 50 degrees, and that equals the opposite end divided by the adjacent side, which is 6. Okay, so for all of these, what you can do is basically use a form of cross multiplication for all of them. So for the h, I'm going to want to cross this h up and over, and then the sine of 30 down. And then if I take 4 divided by the sine of 30, then I get an answer of 8. For the second one, I only want to cross the 5 over, and that already isolates my unknown variable. So for this one, we did want to have them switch places because that isolated the h on this side. But we're going to cross the 5 up and over, and if I take 5 times the cosine of 40, then my adjacent side equals 3.83. For the final one, the tangent of 50 degrees equals the opposite over 6. This one, again, I'm just going to cross the 6 up and over. So tangent of 50 times 6 gives me my opposite side, which is 7.15. Okay, so that's how you use the three different trig functions. So you basically ought to see what you have, what you're looking for, and then find the appropriate trig function that matches both of those things. It has one of the things that you have and one of the things that you're looking for. Now let's take a look at the Pythagorean Theorem. This would be something that's commonly used to find parts of a triangle. It is used in a bunch of different areas in math, you would be tightly tied to trig because you're taking a look at a lot of triangles when you're doing trigonometry. So if we're taking a look at this, Pythagorean theorem is a squared plus b squared equals c squared. So if you're taking two of the sides, squaring them, summing them up, they are equal to the hypotenuse squared because that's the longest side of our triangle. So we'll just take a look at these two fairly quickly, and then I'll move on and I'll tell you the last two important parts in understanding the fundamentals of trig. So if we're taking a look at this triangle, we're looking for our hypotenuse. So I'm going to go with 3 squared plus 4 squared equals c squared. And 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. And we finish off the problem by square rooting both sides. And then our c equals 5. Okay, for our second one, we have our hypotenuse and we're looking for this side, and I'll just call that A because that's how I label it over here. It doesn't really matter which one is A or B as long as you use a side that's not the hypotenuse. So I'm going to call this A squared plus 16. Oh, excuse me. It's actually 4 squared, so I'll write it down as 4 squared. Okay, which is 16, and that is equal to 5 squared. So for this one, it is actually the same triangle as this one, but I'm just showing you the setup, solving for two different unknowns. So this side is 25, and this side is a plus 4 squared, which is 16. So if you subtract 16 from both sides, you get a squared equals 9. And then same thing, you finish off with square rooting the number, and then you get a equals 3. Okay, so that's pretty much it for Pythagorean theorem. Again, because you're using a lot of triangles when you're doing trig, the Pythagorean theorem might come into play, and it's a pretty quick and easy way to solve for a certain side of your triangle. Okay, now the last two parts I'm going to mention are the inverse trig functions, and those are if you want to find an angle. So for each of these, they're designed to find a certain side of the triangle. But what if you have certain sides of a triangle, but you want to find an angle? What you would use in your calculator is called the inverse sine function. So what I would do for the inverse sine functions is this. So say, for example, my 30 degrees was my unknown angle. I would take the inverse sine of 4, which is my opposite end, over 8, which I now know is my hypotenuse. And then when I would put that in my calculator and press enter, then it would tell me that that unknown angle is 30 degrees. Okay, so it's basically just the exact opposite of what we did over here. You have all the sides, but you are looking for an angle. So basically the same thing with the inverse cosine and the inverse tangent. So let's just take a look at one more. So if we were looking for this 50-degree angle, that was our unknown. We would do the inverse tangent of the opposite side, which we now know is 7.15, divided by the adjacent side of 6, and then press enter in my calculator, and then that would give us our 50-degree angle. Okay, so inverse trig functions, those are used to find a particular angle. You just have to take a look at what two sides you're working with in relation to that angle, and then pick the appropriate one based on what you have and what you're looking for. The final idea I'm going to talk about is the reciprocal of our original 3 trig functions. So for sine, the reciprocal is cosecant, written as CSC. So the cosecant of the angle is the reciprocal of the ratio that is used for sine. Sine is opposite over hypotenuse. I'm just going to flip those, and it is hypotenuse over the opposite side. And then for cosine, the reciprocal is the secant, which again, I'm just going to take this over here and flip it, and then I have the hypotenuse over the adjacent side. And then for tangent, the last one, the reciprocal is cotangent. And then we're going to put the adjacent side up top, and the opposite side on the bottom. Okay, so if I were to use one of these, it basically serves as a similar function that sine, cosine, and tangent would be. And that function is to use an angle and use a side of the triangle and then find another side of the triangle that's unknown. So say, for example, if I wanted to grab the angle of 30 degrees and I was looking for the hypotenuse over here, as the original problem was, I would say the cosecant of 30 degrees equals, and then the hypotenuse is my unknown, so I'll write h on the top. And then the opposite side of that 30 degrees is 4. So then I would cross multiply the 4 over, and then 4 times cosecant of 30 would give me an h of 8. Okay, so it's very similar to this. Like I said, that's why it's the reciprocal. It's basically just like flipping this ratio, but you're basically using it for a similar goal of using an angle and a known side to find an unknown side of the triangle. So I hope that was helpful and helping you understand and apply the basics of trigonometry. Thank you for watching and listening.